We have some demos for you today, and we have a short little introductory talk. Cyril Hirschel and Simon Payne are here, and they want to talk to you a little bit about the apps that they developed. Cyril was actually just telling me that last year he came to one of the App Engine talks, and he heard about a new API, and he went and built a game on top of it, and he wants to tell you about that now. So take it away, Cyril.
I will switch to Czech if you don't mind, but the slides are still in English. So, dobrý den. My jsme vytvořili takovou logickou hru, která je variací na známou hru, na známé puzzle, kde se spojují barvy. A minulý rok jsme mluvili s Fredem a on nám řekl o Google Channel API a na základě toho rozhovoru jsme zkusili implementovat multiplayer do této hry a tuto hru potom implementovat na Facebooku, kde si ji můžete vyzkoušet a můžete hrát v reálném čase se svými kamarády takovouhle hru na odreagování. V čem to spočívá? Máte v prohlížeči taková dva trouhelníky, kde ten horní má kameny, které jsou obarveny barvami a cílem je ty kameny přenést do toho spodního trouhelníku tak, aby všechny barvy na sebe lícovaly. Tu výsledek máte na té spodní části, tak to má vypadat to složené puzzle. Když si stáhnete tu hru, pustíte si ji ve Facebooku, tak můžete si zahrát single player, tam máte 3 možnosti podle obtížnosti, můžete pozvat přátelé do té hry a potom s nima hrát multiplayer, což vyvoláte stisknutím toho challenge, že vyzvete toho kamaráda, abyste soutěžili o to, kdo bude rychlejší. Můžete komunikovat, můžete přemisťovat ty kameny pomocí 2 kliků, že kliknete na ten cíl, obarví se vám všechny možnosti, které do toho cíle patří, anebo kliknete naopak na ten zdroj a obarví se vám všechny možnosti, kam ten zdroj umístit korektně. A nebo můžete použít drag and drop a přenášet drag and dropem. Pro vás, kteří jsou familiární s těmito technologiemi, tak tady máme výpis, na základě čeho je to napsané. A teďka přejdu asi k reálné ukázce, abyste viděli, jak funguje nebo nefunguje ten multiplayer. Já jsem teďka pozval Šimona ke hře, jemu to se tam objevilo, aby tu hru přijmul, což už udělal a budeme teďka zkoušet, ale nekoukej se tam, prosím tě, složit co nejrychleji. Tady vidíte, když já kliknu, tak se tady vyberou všechny možnosti, které tam pasují. Tak já hledám radši nějakou takovou, kde pasuje jenom jedna možnost, protože mě to ulehčí potom další možnosti. Většinou ty možnosti, kde jich je málo, jsou někde v rohu, kde jich moc nepasuje. No, tak teďka trochu... Tady vidíte, jak on pokračuje, jo, takže on je teďka trochu na tom líp. Tak já risknu, zkusím si těch 2 zvolit jednu, která nejsem si 100% jistý, že byla správná a tady jsem narazil. Jo. Už do tohle políčka žádná jiná není. Tak se musím vrátit a zkusit nějakou jinou. Jo, tak teďka mě vybírá už použité políčka, takže jsem taky... Tak zkusím nějakou další možnost, která je jednoznačná, tak on mě tady nebezpečně dohání. Kdybyste měl někdo nějaký tip a už to viděl, co tam mám položit, tak mi řekněte, nebo to chtěli vzít za mě. No, tohle bude premiéra. No. Chce si to někdo zkusit? Tak už to... No tady se totiž může stát ještě, že vy máte skoro celou tu hru postavenou a teďka poslední políčko... Jo, už to má. No, tak gratuluju. A my jsme připravili takovou výzvu na stránce tetrigon.com, tak tam je velký tetrigon, který si můžete zkusit složit. Nám to ještě nepodařilo a když budete první, tak vás tam uveřejníme a budete slavní. Tak děkuji moc a předávám slovo Fredovi.
Děkuji. Thanks, Cyril. Thanks, Simon. So you came here to hear about HTML5 games and how to build those in the cloud. In fact, you came here to hear about kick-ass games, which are just really, really awesome games. So let me just switch over to that presentation. Okay, here we go. So the agenda for today was going to be a quick survey, which means I want to know how many of you here are either professional game developers or spare time hobby game developers. Wow, that's quite a large number. Okay, and how many of you already use App Engine before? Okay, great. And how many target HTML games? Now this number needs to be higher. Okay, so hopefully at the end of the talk you'll be motivated. I'm going to do a little quick introduction of the technologies we use, and then talk about why we use each one of those, how you can go use them, and then talk about some specific things to the cloud about persisting data, things like high scores, and then some tricks of the trade. Of course, along the way, I have a bunch of fun little demos to make sure everyone stays awake. So one of the main kind of frameworks or APIs that binds this all together and makes this possible is an open source project called PlayN, for PlayN or PlayN, and it allows you to target HTML5 browsers, but it allows you to use the same source code to compile that application, that game, to Android or to Flash, or to run it on your desktop in Java, so that you're really productive as a developer. And you're like, well, is this real? You know, is this like just a little toy game? I'm going to play solitaire on HTML5, or am I going to do like a real fun game that's actually important? So actually what I want to show you is the very first game that was built with PlayN. You know, of course, Angry Birds has already been popular on the mobile phone for a very long time. But until recently, until May actually of this year, fans could only play the game on a mobile device. They couldn't do it at their desktop. They couldn't do it at work unless they got their phone out. And you want to be able to do it on the big screen. So one of my projects was to work together with the developer and bring, together with other colleagues of mine, Angry Birds to the web. So let me just kind of show you that, in case you haven't seen it yet. Now, how many of you have played Angry Birds? Yeah? Yes, that's what I expected. Okay, so you're very familiar with this. Get going. So I haven't played any levels yet, so I have to beat level 1. Let's get some pigs. Break the castle down. All right, so we all know how this game works. Take the bird, sling it back, fire at the castle, knock the pigs down. Hey, pretty good, huh? First time. So this game it's not a Flash game, it's an HTML game. So what you're looking at is a canvas tag running WebGL. So it's a 3D rendering engine, graphics acceleration, but we're projecting the game on a 2D perspective. And we're updating the screen about 60 frames a second. And we're doing the physics calculation, so figuring out what the trajectory of the bird is at about 30 frames a second. And then we interpolate in between. Of course, Rovio, the developer behind Angry Birds, they were responsible for all the game logic, and they're the ones that made this fantastic game. Some of us on the Google side worked on the open source library, creating PlayN so that you can go build a game like this. So let me just switch back over to where we were in the presentation. So PlayN, why did we pick a silly name like that? Well, we wanted something that was kind of a little bit fun, because we are talking about games. So PlayN is kind of has different ways you kind of see that name. There's PlayN, like he's playing like a rock star. Or playing, I'm playing this game, right? Very, very simple. And then the N in PlayN is really for N platforms. Right now, N is greater than equal to 4, because we have the Java, HTML, Android, and Flash. But maybe in the future, we'll have future platforms. N is always growing. Now why PlayN? Why do we do this? You know, we could have just done a one-off kind of for Angry Birds because that's such an exciting thing. But what we really want is for all of you to go home and build web games, to build web applications, and really make the web a better place for everyone. So we did PlayN because we wanted this cross-compilation capability. We want to be able to target multiple platforms with one source code base. Game developers will tell you it's really, really hard. They have to develop the entire game for one platform, and then they have to do it all over again on another platform. And the languages are different, the tools are different, and it's really hard to get the playability the same, and it's really hard to fix bugs across multiple platforms and maintain releases. So we wanted to fix that. We chose a language that allowed you to write once and then play anywhere. And we did this because we wanted developer productivity. We wanted you to focus on building the games or building the apps and not kind of hassling with the platform and the APIs. We, of course, wanted hardware acceleration. Otherwise, games like this just aren't possible. You need to get all the benefits of the graphics driver. So you need to dig kind of deep into the browser's capability or Android's capability. And we wanted something that was free and open source so that everyone can use it. So when we worked with Rovio, we agreed in advance that the PlayN framework would become open source, even though we collaborated kind of on this first project together. Some of you who are already game developers or maybe not might be wondering why Java? Why not JavaScript? Why not some other language? And we did this really because some of the tools that were already in place, but primarily because of the productivity and the cross-compiler ability. So the fact that we can take Java and we can compile it to ActionScript, we can compile it to JavaScript, we can run it on the Android environment, we can run it on the desktop, and we can do debugging, we can use an IDE and refactor our code. We can work together with a lot of developers. All of this really gives you productivity so you can spend time creating your game, making it fun, making your fans happy instead of the hassles of programming. Java is statically typed. It has every object has a type. So if you create an object foo that is in string, you can't later change that to an integer. If it's a string once, it's always a string. And that means the compiler can do some optimizations. It knows that with that object, it will never refer to any integer methods, and so it doesn't have to include those in the game if you only use strings or only down a certain path. We can do other things where we can optimize the compiled output. Then we can make a smaller version of your code, and once it's smaller, we can optimize it again. We can iterate and iterate until we have the smallest possible game that you have, and Java lends itself really well to that type of optimization. The existing tools were, of course, Google Web Toolkit, which already provides the cross-compiling to HTML5, so we had a great head start there. Java also means that we can reuse the same code. So on the client, we're using Java code compiled to JavaScript, and on the server, we're using Java code and just execute on App Engine. So why Google Web Toolkit? I think I've kind of already made this point, but it's about productivity for you and performance for users, the fastest optimized game. So a very small download footprint, fast execution, code that doesn't get used gets compiled out, just overall good experience. It also means that we can kind of get the benefit of physics libraries, for example. So there's this famous library called Box2D, originally written in C++, that simulates physics in a 2D world. And this is what Angry Birds and a lot of games out there use. They can manipulate objects. There's gravity, there's acceleration, there's velocity, there's resistance, and all these things kind of work together, and objects can interact. That library was ported to Java, once it was in Java, it's actually a half-hour effort or so to convert it to Google Web Toolkit. So let me just show you briefly what that looks like, because it's actually kind of a fun library. So this is GWT Box2D in action. And you can see if you just start up with some initial momentum, you can have little dominoes falling down. You can have all these compound shapes interacting in very, very complex ways. Let me zoom in a little on that. Oh. You kind of see that. This one is really fun because I can also play around with the object. So I can drag one of these ends. I can kind of flip things around. I can take this block and move it around, throw things up in the air. If I'm really good, I can kind of force it through. Like it. There we go. Kind of messed up. Let's throw this up in the air. Bye-bye. So that's Box2D. Some of you might think, why HTML5? Why not just use a plugin technology like Flash or Silverlight or something like that? And really, that's a painful experience for your fans. They come to your game site, they want to play it, and they got to install some plugin. They don't have the right version, and maybe they're on a computer where they're not allowed to install a new plugin. And constantly upgrading plugins manually is a problem. We also wanted the hardware acceleration, so we have WebGL for that. Canvas 2D for browsers that don't have WebGL. We can accelerate in a different way, like IE9. CSS3, in Safari we use CSS3 accelerated hardware transformations to rotate the birds and scale the backgrounds. Web Audio API for real-time, kind of low latency audio, which is what you want for games. You kind of get the picture. We just kind of picked all these technologies because they all have kind of the right attributes. App Engine, another case where we want to serve your game fast. We want to be able to scale to very, very large size, and we want to be able to store a lot of data in the cloud. We want to reuse our Java code in the client so that things about the player profile, for example, they work on the client, they work on the server. So how do you use PlayN? How do you make a game? Well, PlayN is broken out in kind of, you can think of it in these three different sections. We have the core APIs, and we try really hard to keep these core APIs very, very small. We want these to be the minimum set that is necessary in order to play a game. The only stuff that we put in the core API is stuff that can't go anywhere else. So this is truly a very small set for you to kind of learn and get started. And then we have support libraries and game engines. And game engines include things like Box2D, where you would do physics. But that's all kind of external. If you just start with PlayN, you really just have the core APIs. The other thing we want to do is just have a lot of good examples. Rather than give you slides or give you boring documentation to read how it works, let's give you working starter games, Hello World applications. So you can look at some working code, you can make some changes, you can put your own images in there, and you can feel like you're getting something done quickly and get very comfortable with the code. So let's expand a little bit on that first box, the core API, and see how that's broken up. So that further has kind of three things going on in it. There's the main game loop. Now, if you're a game developer, you know exactly what this is. If you're not, this might be a new thing to you. But what a game is, think of how a television set works, is at 50 or 60 times a second, your television displays a new image. And that image is slightly different than the previous image, and your eyes can't tell that things are moving that quickly, and so you see a smooth picture going across your television set. But your television has to produce a brand new picture 60 times a second. So it has 1/60th of a second to produce a single frame. Games are exactly the same way. They want to update. About 60 frames a second is no longer perceived as jittery in your eyes. Sometimes you want to go a little higher, but 60 is good for games. So what we need to do is, in our game, we need to calculate the physics where all the objects are going to be. enough to make the physics realistic. And then we need to paint the screen and all the objects on it in different locations 60 times a second. So this is where the game loop comes in. I'll show that in a second, but it's basically driving your game, constantly pumping another frame. So this is your frame rate. How many frames per second do you do? The second part of the core APIs is the I/O system. This is where you're interacting with resources. You're pulling in things from the network. You may be taking graphics resources and displaying them, or you have audio, sound effects and things like explosions, etc. And the final piece is how do you get those assets? It's different on each of the platforms. On an Android device, it's some resource somewhere on the web. It's a URL. On Java, it's just a local file, and so on. Now, before we look at the game loop, let's look at kind of the hardware acceleration and the rendering, so you get an idea of how things are put together. So we have these different layers. We have the background. We have maybe some stuff in the middle. And then we have all the objects that move a lot. For this, there's a rendering API. And there we have very simple methods. Draw image, draw text, draw line. And this is how you can kind of build the different layers up. So in each layer, the background layer, you might just draw one image. And you scale it, stretch it, shift it around to the right spot. On the foreground layer, you might display the same image many times. You see all those little green balls in that front layer? That's the same image over and over again, but in many, many different positions. And then this rendering API has implementations in Android, in Flash, and in HTML5. And in each case, those platforms have one or more hardware accelerated paths. So in HTML5, on Chrome, we use WebGL. Safari, we use CSS3. On IE9, we use Canvas. On Firefox, we also use WebGL. And those are kind of three different implementations of the same rendering, but you only have to learn one API, and it runs on all of these. So now let's look at the game loop. This is the thing that's driving and pumping your game. So you start by writing this Java class. Remember, you're writing everything in Java, and you're only writing your code once. So this is the same code for every single platform that you're deploying to. So you implement this game, and you have three methods. You have an init method. This gets called once at the start of the game. This is where you can go start fetching resources or building up data structures or whatever you need to do for your game. Then there's the update method, and this is called by the game every time it's ready to update. It's basically called as quickly as possible. And this is where you might do your physics calculations or turn-based stuff. If the monster is going to move and the player takes a move, this is where you update all the coordinates and say, okay, now everyone, they were here, and now these guys are over here. The next frame, they're over here. And every time you call update, there's kind of one iteration, and then things start moving. The final method is the paint method. And this is where you take all the positions of the objects where they are, and you just paint the screen. You render the different layers. And this, on HTML5, gets called at most 60 frames a second, because anything more is just a waste of CPU cycles. Your eyes can't see anything any faster, so we only paint at 60 frames a second. In fact, in the modern browsers, when the user leaves that tab and it loses focus and something else comes up front, Chrome, for example, will stop sending those 60 frames a second. It will just go down to 0. So your game may still be doing the physics, but it no longer has to paint the images. So it doesn't have to use the graphics acceleration, doesn't do all that work. So now let's kind of put this together. So we have PlayN, we have implementations on now at least 4 different platforms. There is one place in your code where you have to do something that is platform specific, and that's this little bootstrap. And you see here it's 2, 4, 6, 8 lines of code. 2 of them are parentheses, so it shouldn't be too hard. And what you see here is the HTML5 version. And there we have an HTML asset manager, and we have, let's see, we set a specific game path that's unique to the HTML5 version. And then we call PlayN.run, and we pass it a new instance of my game. That's that class that was in the previous slide. Very similar to this is the Java version of the game. Looks almost identical, but instead of an HTML platform, we have a Java platform, but we still call PlayN.run. And again, for Flash and Android. So this is the only code that's unique to a platform. Everything else is reusable code that works on all the different deployment platforms. So now that I put you to sleep, it's time for another demo to wake everyone up. Let's see here. Peas. So this is one of those sample apps that comes with PlayN, and it really doesn't do very much other than when I click on it, a ball appears, and I click again and I get another one. But it does let me kind of play with the physics a bit, so I can scoot balls out of the way. I can also bounce them on a trampoline. I can make a large number of balls. And there's a little magic hole here that when they go in, they pop out the other side. And of course, very quickly, this becomes a lot of fun. So that's peas. That's one of the samples you get. But you see a lot of things go. It will never stop. We need a few more, though. You see the background happen. You see this cloud going by, and you actually see two clouds going at a different speed. So there's two different layers, and it's called parallax scrolling when they scroll past each other. So if you ever are driving down a long road and you look out in the distance, and you see the sun kind of stays in the same spot, but the trees maybe move slowly, and then the fence that's right next to the road goes really, really fast. You see that everything's moving at a different speed. That's the parallax effect. And so this is something that you use in games when you have someone shifting along. You move the background just a tiny bit, and the layer in front of that a little bit more, and the layer in front of that even more, and then the final layer you move a tremendous amount. And it gives this effect of depth, of 3D. The other one I want to show you here is a cute game. This is very cute. So this is an example where you have kind of an infinite not infinite, but a very large play field that is scrolling around in front of you, and you display part of it. I can't pick anything up, but I do kind of bump into objects. That's kind of fun there. Okay. Okay. Time to go back to sleep. So this is kind of a how to build kick-ass games in the cloud talk, not just how to build kick-ass games. So we have to talk a little bit about the cloud and persistence and that sort of thing. So there are two types of things that you might want to persist in the cloud. There's the assets, individual images, audio files, maybe some video. You might have 3D object maps, that sort of thing. And the other thing is state, like high scores, or global positions of where users are in a game, or maybe save games. Maybe I save my progress, I complete Angry Birds here on HTML, and then I want to go on my mobile device and do something like complete level 2. For the first bit, we have different cloud storage options. We have, wait, sorry, I'm confusing you. So let's look at achievements. Let's say we want to keep track of high scores, and we want to keep track of other events in the game. Like maybe I have an adventure game, and I come along, and I find a fancy sword. And now I want to keep track of the fact that I, as a player, have that fancy sword. And I have a score for the first 3 levels. So let's do this, and let's do it in Java, of course. So we have, this is pretty standard stuff. We create a data store service from the data store service factory, and then we implement this method called setAchievement. And this is what your game is going to use every time the player has an achievement. If they complete a level, if they pick up a fancy sword, if they complete the quest and find the magic golem in the box, they get an achievement. And so we're going to pass in 3 pieces of information. We're going to pass in the player ID, that's who had this achievement, and then some key value that we know, that the game knows, and then the actual value, which can be a high score or something else. And what we're going to end up with is this table down the bottom right. That's what we're kind of storing in the data store. So let's say we have a method somewhere where we get or create an entity. If it exists, we pull it in from the data store. If not, we create it on the fly. But in any case, this entity represents an achievement, or a list of achievements, rather. And this achievement is going to have two list properties. List properties are these things. They look like maybe columns on a table, but they can have many values. So if a list property is a number, not only can I put in the number 1 or the number 3, but I can put both in there. I can put 1, 3, and 42, and all three of them fit in there. I'm going to have up to 1,000 values in there. So I'm going to do this little trick. I'm going to actually have two of these list properties. I have one called keys and the other called values. And App Engine will keep them in order for me. It won't mix them up. And what that means is I can actually create this table in the bottom by taking two of these lists and kind of lining them up next to each other. And so you see there, for level 3, I have 4,500 points, and level 4, I have 2,300. And at the very end there, you see a fancy sword, true. Now, in order to kind of update this in our method, we have to see if the existing key is there. And if it's there, then we override the value. So let's say I play level 3, and this time I get 4,600 points. Then I would update that first column there. Otherwise, I have to add the value. So I add it to the end of the list of the keys and the end of the list of the values. And you'll note that they're not in order. They're not sorted any particular way. I'm just kind of iterating through them. And then when I'm done updating my lists, I set the properties, and then I put them to the data store. So what you have here is, for every player, I have one entity in the data store called an achievement, and it has two properties, a keys property, values property, and each has a list of values. And it can have 0 or up to 1,000 different values, so I have 1,000 levels I can support just doing this. And then for each key, I have a corresponding value. Now, we had that little method there, get or create, and I can't really skip over that, so let me show you what that looks like too. So here's a get or create player. And so if a player is brand new and he wins the first level, we have to be able to create the player object. So we do that here. We make the entity, and then we try to, or we make the key rather. We try to get the entity from the data store, and if it's not there, we get a entity not found exception, in which case we create a brand new entity and we put two empty lists in there, and then we return the object. So that's all there is to that. Now, there's a lot of kind of tricks that game developers use, or maybe methods of the trade. These are things that game developers learn from each other. These are common practices. But if you're new to game development, you might not really be aware of a lot of these things, like the animation rate, the painting of the screens. All of this is kind of new stuff. So I wanted to show you kind of some of the other tricks that game developers use. One of the first things you want to do for an HTML5 game is implement caching. Just HTTP 1.1 caching, use standard headers. The browsers will cache the content, your ISP, your internet provider will cache the content, and even Google servers will cache the content. And every time there's cached content and it gets served to a user, that content is free because you're not paying for the outbound bandwidth. Someone else is doing that. And it's quite simple. You just use this header, say cache control, public max age equals, and you provide the number of seconds of the count of this cacheable. And here's the payoff. This is what you get. This is not an exact graph, but I tried to kind of replicate it mostly. This is one of the developers recently. He emailed and said, I just turned on caching finally, and look what happened to our traffic. And the game's still serving to just as many users, but as a developer, you're not paying for all those bytes to leave a Google data center. Instead, some of that content's being served by other servers on the internet, or never being fetched at all. If the browser caches it locally, when the user plays the game a second time, maybe it's a week later, they have that content all sitting on their web browser. If you're an App Engine developer, there's another trick that you use, which is you use memcache. Memcache is about 10 times faster than going to physical disk. And you should only do this is the way I like to say this, you should only do this if you care about your users. If you don't care about your users, then you should use the slow method, much better. Sorry. So it's quite simple to implement. Imagine that you have you have two methods here, load player and store player. And this is when a player enters the game, you have to kind of load their state off of disk or somewhere in the data store. And when you're done, you have to kind of store the player data. And the only thing you really have to do is you add these calls to memcache here. So if you walk through the load player method, you see what we're doing is we first say memcache.get. And that is about a 2 millisecond round trip. And we try to get it from memcache. And if the data is there, then we're lucky and we're done and we can return to the user. So we return a fast response. If that doesn't work, if the entity is not there in memcache for some reason, then we have to fall back, or we have to actually go to the data store and fetch it, which is about 10 times slower, but it's still really fast. It's 20 milliseconds. And then we put it in memcache so that next time we try to get it, the data will be there. Then when we update the player, we want to be sure to clear memcache. So we just have a memcache.delete there at the very bottom so that the old value is not retrieved, but instead we get the most up-to-date one. Now, a very, very common technique in game development is something called spriting. Spriting is where you take multiple images, and they can be from the same kind of character in a game, or they can be different unrelated objects, and you put them together into one big sheet of images all stacked together. And you do this for performance reasons. You do this because storing many individual images is much less efficient than one large image. The example you see here is, it's kind of for a desktop application, but you see 11 images there, kind of all loose. And then the arrow pointing down, now you have this one strip of images all strung together. In the top right, you'll see two graphs, and they show you how many bytes it takes to store 11 images versus one image. And you see it's about 21K for the separate images and about 7K. And the difference is simply due to there's metadata stored with every image, like who created the image and that sort of thing, but also shared data, like color sheets, which colors, which pixels map or which color values map to exactly which colors. And then there's just the format overhead. If you have like a JPEG image, there's a kind of a header at the start of a file, and there's some structure inside of it, and all of that's overhead. So we can get rid of all of that. The more important thing for an HTML5 game, though, is the network round trips. If you look at that kind of staircase graph there in the bottom left, you see there's a website that is fetching a lot of images, a lot of individual images. And the way the browser does them is it can parallelize some of that, but it essentially has a limited number of channels and can only make so many fetches at a time. So if you have 100 different images, or maybe even 500 different images, which would be very common for a game, you can wait a very long time just because of all the HTTP round trips. Every time the client has to talk to the server and say, give me the next image, and then get a response. Give me the next image, give me a response. Those round trips can really add up. So just to kind of illustrate that, if you do this calculation, I basically looked at how far it was from California, the office where I work, to Prague, and it was about 9,500 kilometers. So we have to go there and we have to come back. So that's 2 times 9,500 kilometers divided by the speed of light is about 63 milliseconds. So that means if I had a flashlight and I just shine it, and then in Prague you're here with a mirror and you hold up the mirror, the light comes back and then I wait to see the reflection, that will take 63 milliseconds, just going straight path. In the real world, light doesn't take a straight path. It's not all fiber between California and Prague. There's routers and switches and cables and infrastructure. So I just pinged a couple of sites and took the average, and it seemed to be about 220 milliseconds. 5 of those is 1 second. 50 of those is 10 seconds. So if you have 50 images, then the user's waiting 10 seconds for nothing. Those are just the requests. That's not transferring data. If you have infinite bandwidth, unlimited bandwidth, you have a piece of fiber like this big, and you request 500 images sequentially, you wait 10 seconds at the speed of light. So this is why these round trips matter. you really want to combine images. So let me show you just an example of a sprite sheet. We'll just use the Chrome developer tools to see what that looks like. This is a very fun game, as you can tell. So I'm better at Angry Birds than this game, clearly. Okay, so let's look at some of the resources here. Look at some of the images. You can see we have some blocks, some basic things there. But here are our sprite sheets. So this is a guy that's celebrating, and you can see if you painted one image after the other, that this guy's going, yeah, like that. This guy's dying. He's like falling over forward and just face flat on the ground, and then he's dead. We have a few more. We have different characters, and then this is him jumping. Every time you jump over something, the game plays these little animations. But you can see this is a single image. Link in 10. So it's one image, and the game will cut out different pieces of it. So it will show different parts of it. I can maybe sort of give you the effect. If I go back and forth, I don't know if you can see that. Yeah, a little bit jumping. So that's a sprite image, or an image sheet. If you're running your game on SSL, there's a few tricks. One, you can sign up for the Trusted Tester program, which just was announced I don't know, within the last 2 days to get custom SSL certificates. But if you want to run on appspot.com, we have a fun little trick. First, I need to tell you the problem, and then you'll understand why this trick is fun. So when you go into appspot.com, we serve a certificate, a Google certificate, that is valid for the subdomain. And unfortunately, these certificates only work for one subdomain. If you actually open up the full details, you'll see that we say 2 levels deep, but the browsers don't actually support that. So you're stuck with this 1 level deep, something.appspot.com. Now, of course, you get your appid.appspot.com, but you might need to do other things. And that's because if you want a version-specific URL, you get version.appid.appspot.com. Or if you're using backends or backend instances, you have these deep URLs that want to go several levels deep. If you do that on HTTPS, let me show that. You'll see what I mean by this. So version dot so that works fine, but if I do HTTPS, then we get this very ugly warning error that's going to scare all my users, and it should scare them. Hopefully they don't click past this. So this is maybe okay if you're running like in a backend for an Android device where there's no user visible error messages, but this really isn't okay for regular users. So our trick is we replace all dots with this dash dot dash, and thereby we make it one subdomain, and now it just works because it's 1 sublevel deep, and App Engine does the mapping. So we can even go to instance 0 dot backend foo. Of course, we have to add the dash dot dash. And that doesn't exist, but you see the certificate's valid. We get the nice little green HTTPS there. So that's what we're looking for, valid certificate. So that's my little SSL trick. Now you see why that's fun. Another thing you could do is we just have, in the Google Plus APIs, we have the ability for you to go into the user's profile and get their profile picture, get their kind of their stream or their public content. So it's a really fun way to add someone's avatar to a game. So they're playing the game, and kind of like you saw in the keynote with the little guys, it'd be fun to have your picture on the guy. Maybe instead of slinging the bird around, you could sling your face around. That would be kind of fun. So this is how you do it in Python. Basically, there's this service that you call people, and then you can say user ID equals me, and that means yourself. And then you can spit out some HTML after you execute the call, and you get an image URL for the profile picture. You can add a size parameter to it, and voila, you have someone's picture on the icon. If you want, you can take it a step further with the App Engine Images API, and maybe you can kind of cut it out so that the face kind of fits on your little avatar. That might be fun. Now, Angry Birds also works offline. So when I'm on the plane, flying between cities and no internet connection, I can play Angry Birds offline, even though it's in a web browser and even though I type in a URL. And that's thanks to HTML5 app cache. It allows you to make games playable offline. And it's quite simple. You simply specify a manifest in your HTML file. And this manifest has a special format. It declares all the resources, so the browser knows which files to fetch, and it stores them in a special place in the browser. And it marks that URL as being special. So now when you're offline and you go visit that URL, it says, oh, this is an offline app. And it grabs those resources and plays them. Inside your web.xml, you also have to declare a special MIME type. It has to be exactly this MIME type and nothing else, otherwise it won't work. And then inside PlayN, we use, for your GWT app, you have a GWT module file, and you just have to add one line there. You say add linker, name equals appcache linker. And then we do all the rest of the magic for you. Then one final trick, if you have a game that's larger than 5 megabytes, which is the maximum specification allowed, you can set this special permission for Chrome Web Store apps. And then your game listed in the Chrome Web Store can be installed for offline use. Angry Birds is fairly large, so it's larger than 5 megabytes. So we use this permission to make sure that you can play Angry Birds while you're offline. Another thing you run into with HTML5 games is this problem called cross-origin resource sharing. And this is basically a new security issue because of the new capabilities of the web. So for those of you that already have been doing web development for a long time, you know that you can have site a.com with an image tag, and that the source attribute of that image tag can point to b.com. And that's okay. Browsers let you do that. So it's called hot linking. You can take an image from one site and kind of inject it on the other site. That is, it's not really so much a security concern, because the user in the browser can't do anything with that image other than show it on the page. So you can kind of steal an image, you can steal bandwidth from someone by, serving make them serve the images on your page, but that's about all you can do with it. What's new in the WebGL world is you can manipulate the pixels. So in WebGL, when I download an image, I can slice that image, I can cut out pieces of it, I can see the pixel values, I can transform that image. And that becomes a real security issue, because now a website on a.com could fetch an image from somewhere else, and maybe that image has valuable information, like maybe it's a report, maybe it's generated server-side, and it could steal kind of the values off of this. So to protect their users, browsers have locked down cross-domain or cross-origin resource sharing when you're using WebGL for hardware acceleration. And that means you have a problem. If you want to serve your assets over here, but your game is on this domain, that really doesn't work. So the answer is a feature that the client and the server both have to opt into, and this feature is called CORS, or cross-origin resource sharing. So in the client, what you do is that you can do the same image tag you did before, but you add one extra attribute. And you just say cross-origin equals anonymous. And what that's saying is telling the browser, you can go fetch that image, but don't pass any credentials. I only want the image if it's like publicly available. Go give it to me. It also means that the browser will send a special header. So that looks like this. The browser sends an origin header. So it's telling the remote server, b.com, that this request came from a website hosted on a.com, a different origin. So this is a warning to the web server that this image is being accessed from content that's not controlled by b.com. It's on a different domain. At that point, if the server responds in the normal way and just serves the image, then the image will not be available. In order to opt into this mechanism, the server has to send this special header back. This is the access control allow origin. And it basically says, yes, I agree. This content over on this other domain, I trust it, and it can have this image, or it's okay. If you really don't care and that image is not protected, you can specify an asterisk or a star, and then it's just allowed. In addition to this header, there are a few others where you can kind of control the capabilities. You can say this is allowed for a get, but not a post, or only a post and not a get. You can do all sorts of things with that. And very similar to this, if you're using Flash content, maybe to play audio files or something like that, a very similar mechanism of delegated security or allowed security is crossorigin.xml, which many of you probably heard of. But the CORS is kind of the web, the modern way of doing this cross-domain protections. And we've learned a lot from older attempts of kind of solving this problem. Now, if you were at the earlier talk, you heard a little bit about App Engine backends. Backends are like front ends, but they're configurable in size and shape. And you can have up to, I think it's 20 of them, and you can have long-running processes. You can keep some game state. You can sort of interesting things like that. So one of the things that is useful sometimes is to have kind of a stickiness where if a client connects to one backend, the next time they connect to the same backend. And so here's how to do that. In Python, you can use backends.yaml. And here I have specified a backend. I've called it RPC. That's just the name I've given it. And I say I want up to 20 of them, but it's dynamic. That means if there's no traffic, I want 0. But as more traffic comes in, I want to spin up more and more instances. And then I want them to be public. That means external websites or external clients can get to these backends. They're not private just to my application. Now, any of your clients that want to talk to that backend, they can go to this URL, rpc.yourappid.appspot.com. And App Engine will randomly kind of pick one of the available instances. If 6 of them are running, it will pick one of those 6. Or if they're all busy, maybe it will spin up a 7th one. And now you're talking to a specific backend. But if you were to make another request to this URL, you might get a different backend. And what you really want sometimes is the stickiness. So what you can do is on the server, you can determine which backend you're on. Here you can call backends.getInstance, and it will say 5. So now you know you're on instance 5. And when you respond to the client, you can say, oh, by the way, I'm on number 5. So if you call back and you want to talk to me, call back on number 5. And then so subsequently, I guess 3 here, in this case, the client can connect to 3.rpc.fredasa.appspot.com, and they will connect to the same instance they saw before. So, what I'm really interested in seeing is who is going to join me up here next time and show off the HTML5 game that they're going to build using PlayN and App Engine and GWT and everything. Or if you don't want to come up here, if you just want to send me a private email about the game you've built, or you want to post about it at Google Plus or something, I'd love to hear it. Thank you very much.